Hello, I am Nandana Satyan from First MCA, Department of IT, Kannur University. Today, I am presenting seminar on topic working of Java Servlets. Java Servlets are an important technology used in web development to handle client requests and generate dynamic web content on the server side. In this presentation, I will explain how servlets work, their life cycle, and how they interact with web servers to process user requests. Firstly, I am explaining what a servlet is. A servlet is a Java-based server-side technology used to create dynamic web application. Unlike static HTML pages, servlets can process user requests, interact with databases, and generate responses in real time. First, servlets act as a server-side component, meaning they run on a web server and handle client requests dynamically. Second, they follow a request response model. This means when a user sends a request like clicking a link or submitting a form, the servlet processes it and sends back an appropriate response. Finally, servlets are considered the core of web application because they help build dynamic and data-driven content efficiently. So overall, servlets play an important role in connecting the user interface with backend processing. This slide explains how web technology evolved from CGI to servlets. First, looking at CGI, Common Gateway Interface, in traditional systems, every user request created a completely new operating system process. This was very heavy and inefficient. For example, if 1000 users access the server at the same time, it would create 1000 separate processes. This consumed a lot of memory and often caused server crashes under heavy load. Now coming to the servlet advantage, servlets solve this problem by using Java's multithreading. Instead of creating a new process for each request, the server creates just one servlet instance and handles multiple requests using lightweight threads. Because of this, servlets are much faster, more scalable, and use memory more efficiently compared to CGI. So overall, servlets replace CGI by improving performance and handling large number of users effectively. The slide explains why servlets are widely used in web development. Firstly, platform independence. Since servlets are based on Java, they follow the write once, run anywhere concept. This means the same code can run on any system without modification. Next is superior performance. Unlike CGI, servlets do not create a new process for every request. This reduces overhead and results in faster response times. Then high scalability. Servlets can handle many users at the same time using threads without creating multiple processes. This makes them suitable for large-scale application. Finally, secure and robust. Servlets benefit from Java's built-in security features and automatic memory management, making applications more reliable and safe. Overall, servlets are efficient, scalable, and secure, which makes them a strong choice for web applications. This slide introduces the concept of a web container, which is essential in Java web development. A servlet cannot operate independently. It needs a runtime environment, and that's exactly what a web container provides. A common example is Apache Tomcat. It acts as a bridge between Java code and the web server. It manages the servlet lifecycle in its service distro. It handles URL mapping, sending requests to the right servlet. It takes care of network tasks like HTTP handling and responses. Overall, it simplifies development by handling backend details so developer can focus on the logic. In this slide, this diagram shows how a request flows in servlet architectures. Here, the client sends request, server forwards to container. Container creates objects and assigns a thread. Servlet processes and returns response. Overall, the container manages everything, that is by making request handling efficient and structured. Slide shows the full request response flow step by step. First, a client sends a request like clicking submit. The web server passes it to the web container. The container creates request and response object. Then it assigns a thread and calls a servlet service method. The servlet processes the request and prepares the response. Finally, the response is sent back to the client in HTTP format. In short, the container handles a full request response cycle automatically. Slide shows that the servlet lifecycle has three main phases: init, service, and destroy. The init is called once when the servlet is loaded, mainly for setup tasks like initializing resources. Service is called for every request where the servlet processes client requests like do get or do post. Destroy is called once when the servlet is removed or the server shuts down to release resources. Overall, the web container controls the entire lifecycle automatically. This slide explains how HTTP request and responses works in servlets. First, we have request handling. In this, get is used to retrieve data, post to send data, put to update, and delete to remove resources. The request object contains all client data like headers, parameters, cookies, and session info. Next is the response generation. In this, the servlet set content type, adds headers, writes data, and sets status codes like 200 or 404. The response object then sends a final output back to the client. In short, the request comes in with data, servlet processes it, and response is sent back with results. This is a simple example of a servlet program. We create a class that extends HTTP servlet to handle HTTP requests. The doGet method is overridden to process client requests. We set the content type to HTML so the browser knows how to display it. Then we use print writer to send output back to the client. In this example, it simply displays hello world on the browser. This shows how a servlet receives a request and sends a response using basic code. Nextly, we can look at the main advantages of Java servlets. Firstly, it is the performance. Servlets are fast because they use lightweight threads instead of creating new processes for each request. Secondly, it is the portability. Java follows write once, run anywhere, so servlets can run on any server like Tomcat or Jetty without changes. Thirdly, it is the security. Java provides built-in security features like memory management and strong type checking, making applications more secure. I am concluding my seminar by saying Java servlets are a key part of web development for building dynamic server-side applications. They efficiently handle request and response using a scalable, multi-threaded model. Servlets also provide clear lifecycle management and reliable performance. They are widely used in real-world applications like web apps and backend systems. Overall, understanding servlets give a strong foundation for advanced framework like Spring and Jakarta EE. In short, servlets are powerful, scalable, and still very relevant in Java web development. Thank you.